Hi students, and welcome to your lesson for 8th grade, Unit 4, Lesson 2. Anytime that we do recorded lessons like this, my expectation is simply that you follow along with the video, watch it in its entirety, and then take any notes that I'm writing on the screen in your book on the appropriate pages. So go ahead and open to Unit 4, Lesson 2. And we're going to begin with this notice and wonder called hanging socks. And if you have a sibling around, or maybe a parent or grandparent around who you can discuss this with, I encourage you to pause the video, take a look at this image, and ask yourself, what do I notice and what do I wonder? And see what you come up with. All right, well, I'm hoping you gave yourself some time to think about this and maybe jotted some ideas down in your book. But what you can see and what you probably noticed is that the pair of pink socks they're even, they are equally weighted. And then this pair of blue socks, this blue sock looks like it's heavier than this blue sock. And you might have wondered why that was happening or why it was uneven. Maybe you made a guess that said the left sock is possibly like just out of the washer and is still wet, and the right sock is dry, or maybe there's something in the left sock to weight it down that's not in the right sock. I don't know, maybe you just made some guesses about that. So this is something that in a weird way is going to relate to what we're talking about in math today. But instead of working with socks, we're going to be working with these hanger diagrams. So just like a clothes hanger, this is a hanger diagram. And a hanger diagram represents a balanced diagram. So it represents that there's equal weight on both sides of the diagram. And right now we're only going to be working with 2 things that are hanging, but eventually we might have 3 or 4. And the problems can get a little bit more complicated, but for today we're just working on hanger diagrams that have 2 sides to them. So let's go ahead and attempt these first 2 problems in your book. So it says the picture represents a hanger that is balanced because the weight on each side is the same. So we can see, let's just take a moment to look at this. We have 3 blue squares on the left along with 2 triangles. 1 blue square on the right along with 1, 2, 3, 4, 5 triangles. So in problem 1 right here, it says Elena takes 2 triangles off of the left side and 3 triangles off of the right side. So let's see, 2 triangles off of the left side. So let's go ahead and do that. 1, 2. And 3 triangles off of the right side. So let's go ahead and do that. 1, 2, 3 off on the right. Will the hanger still be in balance, or will it tip to one side? If it's going to tip, which side will it tip to? And then explain how you know. So let's think about this for a little bit. Right now, the hanger is completely in balance, correct? Well, let's go ahead and I'm going to back up and undo these cross outlines here. Essentially, let's see, we're taking 2 off the left and 3 off the right. So essentially, we're kind of cutting it right here. We're taking 2 off here and 3 off here. Will it still be balanced? What do you think? Well, let's experiment. So first of all, remember that it's balanced. If we take one off here, we take this off here, that means this side is going to be lighter. So the right side is going to be heavier. It's going to tilt down an angle like this. Now, if we take another triangle off, would you agree that if I take a triangle from here and a triangle from here, the hanger would still be balanced? Hopefully you said yes, because I took an equal amount from both sides. I took this triangle off and I took this triangle off. They're the same. I took them off and now they should still be balanced. Let's see if I take another triangle off. I take this triangle off and one from the other side. Is my hanger still in balance? Yes, it is. I agree. So this is a hanger that's still in balance. I've taken 2 triangles off from the left and 2 triangles off from the right. So I still have a hanger that's in balance. Now what happens if I just take one more off? I didn't take one over from the left side off. I took one on the right, without taking one from the left. So now my left side is going to be heavier and my hanger is going to tilt from, it's going to be heavier on the left. So it's going to be tilting down on the left. So our answer for this section here is, will the hanger still be in balance? So I love complete sentences here. So the hanger will not be in balance because we did not take equal amounts from both sides. The hanger will tip to the left. That is an example of a type of answer that I would like on your book. And you can go ahead and write that in. Pause the video now so you can get that written down. And now we're going to move on to this piece that says, if a triangle weighs 1 gram, how much does a square weigh? All right, so now we know we've got some numbers to work with. If a triangle weighs 1 gram, how much does a square weigh? So what I want you to do is go ahead and write a 1 inside of each one of the triangles so that we can see how much weight we know is on both sides. So write the 1s inside of all the triangles. And then once you're done with that, let's go ahead and count up what we know. So right now we know that this side has 2 grams because there are 2 triangles here. And we know this side has at least 1, 2, 3, 4, 5 grams because there are 5 triangles here. But we don't know the value of the squares. And they're asking us, how much does a square weigh? Well, we don't know. But we do know that the hanger is balanced, so we can use that. And we also know from this that all the squares weigh the same. So let me see what I can draw here. I'm going to put a question mark or part of a question mark. I'm going to add my part of my question mark here. And now I've got something to work with here. So I know that the 2 grams plus, oh, it's hard to draw a plus sign with this program, plus the 3 question marks. Well, what do we use typically in math instead of question marks? Typically we use variables. So I'm actually going to use an S for the squares, plus 3 squares. 3 squares plus 2 triangles is going to equal, I'm going to draw this equal sign kind of sideways so we know that this is our equation we're working with here. 3 squares plus 2 triangles is going to equal 5 triangles plus 1 square. 1, and it's an S, not a 5, 1 square. All right, so let's see if we can do some math here. Let's see if we can get rid of something on this hanger so that we can only have 1 square left on either the left or the right that we can work with. So earlier we went through and we crossed out some triangles. So let's go ahead and cross out these triangles, get rid of the 2 from both sides. So that way we're left with just some plain numbers. And essentially what we're doing here is we're subtracting this 2 right here. So subtracting 2. And that leaves us with 3 triangles and 1 square is on this side, and we're still balanced because remember we took 2 triangles here and 2 triangles here, so we're still balanced. So now we have 3 squares is equal to 1 square and 3 triangles. I'm going to write 3 triangles and 1 square. Okay. And now what I need to do is see how else I can balance this. Well, I know that I can get rid of some more things here, and I know I can't take away any more triangles because the left doesn't have any more, but both sides have squares. So let me take away a square. If I take away this square on the right and this square on the left, I'm still balanced. I took away 1 from each. So I took away this 1 square here, and now I have 2 squares over here. 2 squares equals 3 triangles. Oh, that's interesting. Don't we know how much a triangle weighs? We do. We know that it weighs 1 gram. So if I know that 2 squares is equal to 3 grams, I can do the word grams here, maybe. Let me type it, it's easier. Can I now use this information to find out how much 1 square would be? Well, if 2 squares is 3 grams, 1 square, if I divide both sides by 2, divide those by 2, 1 square would be 1.5 grams. So 1 square would be 3 over 2, or 1 and 1.5. 1 point, where's my decimal? All right, pretend that there's a decimal right here where my mouse is. So it's 1 square equals 1.5 grams. And we were able to do that just by making sure that whatever we took away from one side, we were also able to take away from the other side. So now we're going to try this with a different hanger and some different numbers, but it's going to be the same process. We just have to read the directions carefully. All right, I'm actually going to grab a screenshot of this and send it into a different program that I can work with a little bit better with writing notes. Here we go. Okay, so let's take a look at these two problems. It says find the weight of a square in hanger A and the weight of a pentagon in hanger B, given this information. So let's go ahead and write this information in. A triangle weighs 3 grams. Okay, every time I see a triangle, I need to put a 3. And a circle weighs 6 grams. Okay, let me write that in black. This is going to be 6. And we'll fill in all the circles with 6's. Okay, I'm going to pause the video here while I keep doing that, and then I'd like you to do the same. Fill in all of the triangles with 3's and all of the circles with 6's. All right, so let's go ahead and take a look. In hanger A, we have values for everything except the squares, which is great. That's really what we want. So let's see what we can take away from both sides to help us solve this problem. I see that both sides have a red circle, so I'm going to take away at least one red circle. And I see both sides have a blue square, so I'm going to take away at least a blue square. And now I've got some values I can work with. So 3 plus 6 plus 6 is going to give me 15. So I know that 15 equals, how many blue squares do I have left? I have 1, 2, 3, 4. 15 equals 4 squares. I'm still going to use S because we're working with squares. And so if I wanted to find out how much 1 square would be, I just need to divide both sides by 4. And 15 divided by 4 would be my answer. Once you do that, you'll see that 15 divided by 4 is 3.75, or 3 75/100ths. So that's the weight of 1 square. Go ahead and pause the video and try this process for hanger B. I really hope you took a moment to pause the video and try this on your own. If not, please do so now. Let's see what we can take away from both sides that they have in common. Both sides have a red circle, so we can take away those. And both sides have 2 pentagons, so we could take away those. But neither side has the triangles that we can take away or another circle. So this one is a little tricky, and I want to show you why. When we took away the circle from both sides and the pentagon from both sides, what were we left with? We were left with a 6 from this circle here. So we have a 6. And then we were left with the 2 triangles over here, which when you combine them, 3 plus 3 is 6. So when we got this statement of 6 equals 6, remember how it was asking us to solve for the weight of a pentagon? That means that the weight of the pentagon could really be anything in the whole entire world. It could be any number because they're balanced. They don't affect each other. There's 2 on this side and 2 on this side. And so the value of that pentagon could really be anything. So when you write your answer for question 1, the square's weight is 3.75 and the pentagon's weight is infinite answers or infinite solutions, something like that. I'd like you for question 2 to try to write an equation just for hanger A, and then we'll check that in class the next time I see you. Then lastly, I'd like you to do problems 1 through 4 in your practice set and do the best you can. Use your lesson summary if you need additional help.